Today let me introduce the 4G industrial router R40. There are two ways to connect the router to computer. One is computer connect to the LAN port of R40 using network cable. The IP address of the R40 LAN port is 192.168.3.1. It can assign an IP address to the computer. Enter 192.168.3.1 in the browser to access. Another way is the WAN port of R40 and the computer both connect to other router. Then we can enter the IP address obtained by the WAN port of the R40 in the computer browser. Then enter the username admin and password. Password is blank. Click Login. This page is a state of the R40, and it does not need to be modified. Here is the status of firewalls. This is the router list. And system log. Also other logs. You can see the working condition of the device. The system settings can set the time, name, and time zone, and state of the device, and the setting of NTP server, which is a server for automatic time adjustment, and changing the language, which is included in the system settings. In administration, you can modify the password of the device and log in with SSH access authentication. You can implement mini apps into R40 in here, and this is only for developers. Mount points are also provided to developers, depending on your needs. Backup including backup, upgrade, and restore of the device. There are also device states saved. Generating backups and importing configuration use the most, flash. Image is an option for the upgrade parts of the device. You can choose the upgrade package we provide to upgrade it. Next is the network settings. We can see the parameters of LAN, WAN port and 4G interface. There is one LAN switch. You can switch the WAN port to the LAN port. Here is a global network option for the device. The Wi-Fi setting. R40 can provide Wi-Fi for other devices, and can also connect to the Wi-Fi of other devices. For example, if we connect the Wi-Fi of other devices, click Search, and after that, you can connect to the Wi-Fi, or you can add the Wi-Fi provided by a device. Next is the cellular network. After inserting the 4G card in the device, you can get a state of the device's SIM card, APN settings, and GPS options. GPS data will only be uploaded to the cloud platform when the device uses the MQTT protocol. And there is an automatic switching function of the SIM card. If you don't choose it, the device only uses SIM card 1 or SIM card 2, and it will not automatically switch when one of the SIM card disconnected. You can set it according to your needs. The function of DNS is binding the domain name. Next is the function of host mapping. The following is static routes. Then there is the network diagnosis. After the settings, you can ping IP and test whether it succeeds. Next is the firewall. You can set port forwards according to your needs. There is the network shares function. Our device supports 3 VPNs. You can refer to the specific setting method of each VPN. The adding method is the same. Add the name, click Add, then click Edit to modify the parameters of the VPN. Click Save after modification. Go back, click Save again to modify. The method is the same of other 2 VPNs. Here is a remote I/O, the serial port of the device, collection, the status setting of 485 and 232. This is pass-through. The port 232 or 485 of our device can be used as a TCP server, and other host computers can directly access the IP address and port of our device to use transparent transmission. Next is DI/DO setting. Digital input has a counting function, and DO is digital output. The alarm function can also be set below. For example, the state corresponding to DI1 and DI2 respectively, or counting function reaches to a limit, set its trigger alarm. Then there is AI, which is the analog input. R40B is equipped with AI. These 3 input modes can be selected, and it also needs to match with the dip switch on the device, including 0 to 5 volts, 4 to 20 mA, and 0 to 20 mA. We also need to set a range of the sensor. Save all the settings after that, and then it can automatically read the value of the analog input, and then the alarm is the same as the ideal alarm. Modbus RTU to TCP, RS485 or 232 serial port sensor, connected to the configure of the LAN, or the host computer. The configure of the host computer connect to the IP address and port of our device and send Modbus TCP command directly, and then our device converts the command into Modbus RTU, and then corresponds to the serial port device. This is similar to transparent transmission, but transparent transmission is not just the Modbus protocol message. Next is Modbus slave. Our device can also be used as a Modbus slave, which are 2 Modbus slave and TCP Modbus slave. If you choose 2, the serial port cannot be occupied by transparent transmission, Modbus 2. If it is occupied, it cannot be selected. As a Modbus TCP slave, you only need to tick it, and then set one of its ports. I need to cancel it first, because I will use Modbus 2 later. Next is Modbus master. The device can be used as the Modbus master to collect data from the sensor of the slave, or I/O module. First add a name, then click Add. Enter the slave addition interface, The alias can be set by yourself, such as water level sensor. Here is the Modbus ID of our device, which can be filled in according to the ID of the sensor. The following is the data type, including Boolean type, 16-bit, and 32-bit data. Boolean type corresponds to digital input and digital output, which correspond to 0, 1, 0, 2 function codes, respectively. I use 16-bit to add. You can choose the function code of the sensor and corresponding data type. There are 16-bit signed, 16-bit unsigned. The latter is data sorting. Here is the initial value of the register address of the sensor, which is the number of sensors. The following mapping registers can remain default, and the polling period is generally 0.2 seconds or 200 milliseconds. The default timeout is 0.5 seconds. The slave interface. We can choose 485 or TCP slave, or enter the IP address and port of the slave. After setting, click OK to save it. After adding, take a look. Here is sensor name and alias, and the sensor's Modbus ID and data type, as well as function code, the number of register addresses, the mapping register address, and the interface of the slave. If the slave is online, we can click Modbus query, select the slave, data type, slave address, and configure name. After selecting, click to display. Because we are not connected to the sensor now, so there is no value read here. Next is email setting, as well as the SMS alarm function. Enter the SMTP server address, and port of the mailbox. The following is the recipient's email. And then this is the sender's email and user. This password is not the login password of the sender's mailbox, but the authorization code of the mailbox after the SMTP function is turned on. Please use the correct one. We just set up DI or AI. When it is triggered, it will send an email to the specified mailbox. For SMS setting, you can add a mobile phone number that receives text messages. Remember to add the region or country code before the number, and you can choose Chinese or English. Device monitor. R40 can detect the network, some IP addresses of our local area network. You can choose to ping several times. You can link the digital output of R40, close or open, then enable. Choose to save. Event and alarm. You can set alarm content settings. Such as PC1 is off, which means that our first computer is offline, the same as email alarm. After setting, click Save. If there is no content to fill in, the default alarm content will send to your email address or mobile phone number. Next, cycle timer. An alias for timer, followed by interval. Unit is a unit of a time interval, an action, such as DO1, closing or opening, or sending an email. The content of the email can be edited, and the status of the I/O can be sent, and the data of the slave can also be sent. It will send on a particular time, or does not send. You can choose every day, send you the status of the device at regular intervals to your email, or let the device perform some special actions. Here is weekly timer, which allows the device to perform an action every week and every day, similar to the timer. Next is once timer. After the timer is executed once, it will no longer be executed. Add an alias. The month, according to the current time. For example, perform on December 1st, 5 past 11. The device will perform actions at that time. The logical operation. This is arithmetic operation. Different data points need to be combined. Choose a mathematical operation of addition, subtraction, multiplication, and division. Multiply and subtract as much as you want. After the calculation, it can be output to the specified mapping register. After setting, click to publish. Here is the logic operation of the Boolean. When DI1 is closed, you can choose logic or logic and to link other states, and then trigger. Can also be output to other sensors or register address, and take actions. This is a condition operation. After outputting a register address through arithmetic operation just now, we can use this address to output again. Add 1 is the address we output to Reg 4000, and it can be linked to others. It is also similar to the logical operation. Next is Cloud Platform setting. First click Add, then click Edit. You can connect to our V2 platform or other cloud platforms. Take connection of V2 Cloud as an example. Choose Modbus or MQTT. First, Modbus protocol, the Modbus ID of the device, register packet, the register packet of the device connected to the server, heartbeat packet, heartbeat response, heartbeat period, and silence time. Heartbeat is used as a parameter to keep the connection between the device and the server. If you choose the MQTT protocol, there are some fixed parameters. We only need the serial number of the device, which is also the MQTT client ID, and the published topic of the device. Customers need to pay for the serial number if connected to our server. And you can tick the retransmission function. If you connect to our V3 cloud, it is the same as the Modbus V2 protocol of V2 cloud, except that domain name and port, the heartbeat and heartbeat reply are different. Connect to other servers. For example, you can set its server name, domain name, and port of the server, and you can also choose a protocol according to your own server. Taking MQTT as an example, this is the ID of a client of the device, as well as the username and password. The following is encryption. You can choose root certificate or signature encryption. Generally, it is not encrypted. After that, the following is the data format. You can choose default or custom. There is an example here for customization. Using this as a template, which can be modified in the middle. This is published topic 1. You can use the dollar symbol to add the identifier of our device or slave to the corresponding template. If you need to add a timestamp, add a time, and then import it. Next is the publish date, cycle, and quality. If it is the default template, we need to set the publish of the device and the subscription topic of the device, whether to upload the data immediately after the data changes, or to upload to the server according to the specified period. If you want to know how to connect to Alibaba Cloud, Amazon Cloud, and Huawei Cloud, please contact the sales. The Thingsboard platform setting is the same as the official platform. After apply for its username and password on the Thingsboard official website, we can enter the corresponding ones to link the R40 device. If it is a privatized deployment, the IP address and port of the server deployed yourself, the settings refer to Thingsboard official website and then log out. If you have any questions, please contact the sales. Bailai Technology established in 2005. Customers in more than 190 countries and regions. Specializes in designing and manufacturing industrial IoT gateways, edge computing gateways, industrial I/O module, 4G industrial routers, etc. Making IoT and automation